So for the next talk, we have Sangli as the speaker, who is a staff security architect at VMware. Ms. Lee joined VMware in 2020 as a security architect. She had developed interest in security in the early 2000s while she was leading a research team in the area of pervasive computing. Prior to joining VMware, she served in various roles at several companies, including product development, R&D, standard development, and defining product and business strategies. She received her BS, MS, and PhD degrees in computer science from the University of Maryland, College Park. So, during this talk, Ms. Lee will tell us how and why threat modeling is important, what threat modeling is, what it can prevent, and what it cannot, and how threat modeling fits into the overall product development lifecycle and secure development lifecycle. So, this talk will also introduce us to various threat modeling methodologies. So, over to you, Ms. Lee.
All right. Good evening, everyone. I'm totally impressed by the energy that's in this webinar. I mean, it's late in your local time and 200 participants, that's impressive. And I hope that this session will be intellectually stimulating and interesting as well, so that it's worthwhile to stay up, because I'm standing between you and your rest, right? And with that, I want to introduce myself. As Geeta said, I'm a security architect at VMware. In today's session, I want to introduce you to threat modeling, if it is new to you, and not just the definition of it, but I want to give you some sample experience, what it's like to perform threat modeling. So that's my goal. Now, before we get started, I want to set that expectation clearly. After this session, you will not come out as an expert, but I want to give you plenty of foundation that will entice you to practice in your daily life. And with that, one more disclaimer. My slides are mostly figures, and I collected a lot of pictures from the net, and I tried to attribute to it the original owners of it, but if I missed it by accident, please note that these are not my original work, most of it. Now, I would love to have an interactive session in this, enthusiastic audience here, but because it's in a webinar format, I want you to think as I call out different questions and see which one applies to you. And so let's do the first one. Have you heard of threat modeling? I'm giving you a little bit of time, just keep in mind. Have you done any threat modeling? Now, last, to some degree, this is important to me. Do you think it's only a special, exclusive clubs, members of security experts who can do threat modeling? Now, see which one applies to you, especially in the last group. I really want to convince you otherwise. This is not someone who can do only by security expert. I want to convince you that this is something that everybody can do. All right. Before I go any further, I want to bring you to your attention to these 3 books that I find them interesting. And if you have additional interest in learning about it, these 3 books will give you very strong foundation. On the far right, Threat Modeling is a book by Adam Shostack. He's a very well-known figure in this domain, and his book will give you very solid foundation. Now, the book in the middle, Securing Systems, is by Brooke Schoenfeld. I was very fortunate enough to be trained by Brooke, and the way I do my threat modeling was influenced quite by Brooke, and so I naturally have a lot of respect, and he's just phenomenal. So I recommend his book as well. And most recently, I read the threat modeling book on the left corner by Izar Tarandak and Matthew Coles. And so, I especially included the examples toward the end as an exercise, how you can try out the threat modeling. While I did countless threat modeling in my career, it's the outcome of threat modeling is considered confidential, and it's very difficult to construct an example without revealing anything that's confidential, right? So I would have to put a lot of thought into it for me to construct one. But since the authors of this threat modeling book graciously put examples there, I want to share that with you, and then you can practice with me in this session. Now, let's start with what is threat modeling. I'm going to start with two somewhat formal definition from the authors of previous books that I just introduced you to. And then I will add, not quite definition, but what I consider threat modeling characteristics. This is my perspective. So with that, the first one is the definition by the left book. The process of analyzing a system to look for weaknesses that come from less desirable design choices. I underlined design because it is a design. You're looking at the design. You're not looking at the implementation part of it. And what is not said here in this definition is that you want to find these weaknesses at the design time, not after implementation. So just keep that in mind. Next definition is by Brooke. He defines a threat modeling as a technique to identify the attacks a system must withstand and the defenses that will bring the system to a state that's defensive. A system can resist that, right? So here he puts an emphasis on defenses. And if you think about it, previous definition didn't talk about anything about defense. And this you will learn, this is referring to mitigations that you're going to put. So it's not just finding where the weaknesses are, but threat modeling is also giving mitigation on how to avoid it so that your system overall becomes secure. Now, what is the most secure system? That will be one that is turned off and not used at all. But we all know that that has no value, right? And a lot of times especially when I started out my career in security domain, people hear security and they automatically think, even now, they roll their eyes like, oh, those security people, they wouldn't let us do this and that. And so it's almost synonymous that security is a blocker, right? But I want to change that culture. Security is not a blocker, it's an enabler. If you have your system built securely, you can open more applications. You can have a better interaction with your users. So I see security as an enabler. Now, to create your secure system, be an enabler, you will need a lot of tools to make it secure. So threat modeling is just one of the many tools that you will need. So this will help you create a built-in, not bolt-on security. Now, one of the characteristics of threat modeling is it's highly interactive. It's not a one-time activity that you can do and forget about. If you think about it, as you develop your system, is your system static or is it constantly changing? It's constantly changing, I hope. And threat modeling needs to evolve with it. So you will go through this many times. Now, I call this a team sport. It's not something that a special someone does and then everybody is just watching, be a spectator, or just do nothing. It's not that. It's a team sport. There are many, many different parties involved in creating this, and I'll tell you why. In a typical product development scenarios, there are many different roles involved. There's a product owner or product manager or product manager. Yes, product manager or product owner. They own the requirements, set of requirements that they're going to drive. And there's an architect who's going to design the system. Obviously, there are critical members of doing threat modeling, and you will see that in a minute why that is the case. And of course, developers have hands in it in creating this, so they're also very important. Testers, absolutely. If they're not involved, they wouldn't know what to test for it, right? Well, if they are very experienced security testers, they will know, but it is always good to know and have a clear understanding among team members, what are the common objective from the security that we're trying to reach. And so all of these members are needed because they bring different perspective into it. And the more people look at it and do this together, you will have a better outcome. Now, this point, I want to emphasize that threat modeling is something anybody can do it. And I will go one step further, that threat modeling should be done by everybody. And you will see that software developers, especially, there are security engineers. You may not define yourself as security person, but if you think about it, your system that you have written could be part of the entry point for attackers or the weakest point for the attackers so that they can go around and even hack the entire system. So all of you who are software developers, and I would say you're security engineers, and you really cannot afford to not to do this activity. Now, what is this number? 159 to 1. This is a number, the median ratio of developers to full-time software security team members. Think about it. If you just rely on security expert to do the work, then it is very likely that your weaknesses can leak into the product, because it's possible that the security experts do not have time to tackle your particular part of the program or your particular product, right? And so this is another reason why, as a developer or anybody who's involved in this team, to look at it and conduct this threat modeling. So at this moment, I want to bring one example, real world example. I titled it Haunted or Not. And you may recall in 2015, these two security researchers, they hacked into Chrysler Jeep passenger vehicles so that they remotely controlled it. They, while Wired reporter was driving the car, these two researchers miles away controlled the car, turning the wiper on, turning on and off, and blasting the radio sound, raising up and down the windows, giving the driver the haunted car feeling, right? And eventually, these guys demonstrated at low speed, taking over the control of the car. So as you can see that the car is in a ditch. Now, imagine that's you driving. Wouldn't that be scary? Anyway, coming back to my point about threat modeling, why am I talking about this? This particular hack was possible because the entertainment system in the car had a external connection to like say Verizon or something, right? So that the passengers could download, for instance, their choice of movies or programs. Meanwhile, this entertainment system, for unknown reason, had also connectivity to the CAN bus, which is the connection for controlling all the car's control. So they shouldn't have that connectivity between them, but they did. And this is what these two researchers utilized to hack the system. Now, if they had gone through proper threat modeling, that would have been caught. It would have been questioned. Why is this connection necessary? There was no reason they should be connected, but they did. And probably it would have been cut off. Connection would have been disabled, but it didn't. And it was in the market. Now, when a bug is found at the early stage of product development, such as requirement gathering, coding or integration, and even testing, the cost could be somewhat manageable. But as you can tell, that as you discover the bug toward the later stage of the product development, it's a little difficult to see in this particular figure, but it is growing exponentially. Now, if the bug is found after the product is released, then you can imagine that it's even higher to fix that bug. And indeed, that was the case. For Chrysler Jeep, this resulted in massive 1.4 million vehicle recall. And it is estimated that it costs about $10 million to address this issue. So that particular simple design flaw led to $10 million worth of fixes. So just remember that. Now, I want to make sure that you don't get the impression that threat modeling is panacea. It is not. And I'm going to talk about it. So it will not solve all of your security issues. Remember the first formal definition that I brought, which is finding weaknesses in the design at design time. So naturally, threat modeling will not be able to catch implementation errors. And here is one example. Anybody recall Heartbleed? Heartbleed is a weakness in secure connection, TLS implementation, OpenSSL implementation. And in particular, there was the memory length checking that was missing, and which was utilized to extract any information, including critical information such as username and password. And there's a really good cartoon that explains how it is done, but ultimately what happened is that there's a heartbeat between server and client that's sent to make sure that the connection is still active, right? And then a client can send to the server and say, hey, I'm gonna send you a heartbeat of X number of characters. But what happens is that, and then at the time, the server is supposed to send back that many characters back to the client to indicate that they're still alive. Now, on the server end, it was not checking whether actually clients sent that many bytes of information. And so what happened was that anything that was in memory, here the client could send a less number of bytes over to the server, but the server, without checking how many actual bytes came from the client, can just respond with whatever client has sent. So there's a cartoon that you can search, Google, and it'll explain very well. Nevertheless, this is an implementation error. No amount of threat modeling could have caught this error. Now, with that, I want to move on to threat model process. this is a very typical threat modeling process. And you will see on the left side what is called the system model. And you move from system model to identify asset, and then identify threats and attack surfaces, provide mitigations, and I'm going to talk about security requirements. So what this security requirement is about is that you want to have your product, after doing all the threat analysis and which ones that you want to mitigate, and I'll be honest with you, there are sometimes threats that you identify, but the cost of fixing that could be very high, and the chance of this being taken could be very minimum. And you have product development schedule that is very tight, then you may have to prioritize it. So for this round of product release, you may deprioritize that particular attack and mitigation implementation. And so that's going to impact the security requirement. And so this is a typical process. Now, system model and all of these, you kind of go through iteratively and revisit, and until you come to the point where you feel pretty confident that you have found everything. And we're going to talk about when to stop later on. But in this typical threat modeling process, I find that the most time that most of the security, it's not just I actually, most of the security architects, where they spend most of the time is representing the system in the system model. So what is system model? System model is, how do you represent your product or the system that you're building into something that shows how they interact with each other. So it's all, it's like a diagram, system interaction diagram, where you will see an example later on, but it shows how they interact, where the security boundaries are, what are the data that's being kept where, how it's moved around. All of those will be represented in the system model. Now, I'm going to talk about threat modeling, secure development lifecycle, product development lifecycle. It's a acronym soup here. But the very top line, the blue boxes, are typical product development lifecycle. There are requirements, designs, development, testing, and release, right? And the boxes underneath are activities that are sort of mapped into these secure development lifecycle activities that map in. I try to map them into the product development lifecycle. So at the early stage, you try to assess what are the risks, security, privacy risks. And then during the design phase, you do threat modeling. And development and testing phase is where you do code review, static analysis, dynamic code analysis, fuzzing, and all of those. These are not comprehensive list of activities, but I try to kind of represent what are the things that you would commonly do. And before you release, you do pen testing, you do final reviews, and you have a plan on how you address vulnerability and stuff like that. So this is a typical process and where the threat modeling fits into it. So threat modeling goes around the design time. Now you may be asking, okay, who develops multiple model anymore? This is very like linear from requirements all the way to the product release. And actually, it doesn't have to be that way. And I kind of represent it in this circular motion. And I introduced another term called use scenarios. So before you do system models, I tend to gather use scenarios. And I find my brain works to be the best to start from there. Then I can construct the system models, and then I can, go identify assets and threats and attack surfaces and mitigations. This is how my brain works. I have worked with other people who just hears about what the product does and started to just list all the assets or threats. So some people's brain work differently. There's no right or wrong way to start which of these part of the circles, but what I want to put emphasis on is that regardless of where you start, you want to make sure that you go to all of them. Now, coming back to agile methodology, how does threat modeling fit with the agile development methodology? Things are changing so fast. I mean, where does it fit, right? And you can threat model every story. And in my experience, remember that use story, I mean, you can replace it with a story, and use scenarios with the story. In my experience, I've worked with many teams who use agile development, and it's the very first one may take a little bit, but I find it actually very easy to do this very quickly every sprint cycle, and it worked out very well. All right, at this point, you may be asking, is there any threat modeling methodology if you are not familiar with? And you will discover there are many. And then you may be asking, okay, which one to use of all of these many things, right? So I give you a few names here on this slide deck. You can see, I mean, these just a few of them, right? So how do you select which one? Remember Adam Shostack, the author of the book on the right-hand side? He said that a good threat model is one that produces valid finding. That's what's important. And I will go one step further, and I would say that the good threat model is the one that you can find valid findings and you can use. Some of these different methodologies, I encourage you to read about and try it out. And you will find some of them is too cumbersome and it's taking too long. You may not want to use it. And then I would say that's not a good one for you. Find something, and I don't particularly follow one methodology. Over the years, I kind of developed what worked for me. And I suspect that you will also find that, but highly encourage you to try a few of them out. But if you ever want to consider a little bit more formally which one to choose, then I recommend you watch this talk. It's on YouTube, and I believe that I put embedded a link to it, so you can go directly. But otherwise, you can go to YouTube, OWASP AppSec Kali 2019, and you will see this one. And this is the author of the book on the left-hand side, and the threat model book that I recently went through. And the way he selected the threat model, or he provided a little bit more formal way to select a full threat methodology that you could use. And he considered these 7 attributes that's listed on this page. And I kind of screen captured a few shots from his talk to give you the flavor of how he's doing it. So for several of his threat models that he was considering, you will see the outer edges, they're the attributes in the previous page. And he kind of evaluated in this page, it's stride. Okay, stride is very unconstrained and it's not really good for agile. It's pretty useful and all of those, right? Of course, these are his opinion. In his opinion, that's what he evaluated. And then he evaluated stride element compared to stride, how it fits into that structure. And also he did threat library. And then also this is basically expert-led threat analysis. So watch it, it's a pretty interesting one. But at the end of the day, I will emphasize, try a few and find the one that works with you. Now here I'm calling out a couple of methodology for a reason. First one is Linden. Linden is privacy focused. So if you're in a market domain where privacy is really important, I think it might be interesting to check this particular methodology out. In in addition to other ones that you will. The second one is includes no dirt. And it's actually an acronym. You can see in the second bullet point there. This particular one is focusing on privacy and compliance, in particular, clinical environment. So if you're in a marketplace of, let's say, medical devices, this might be interesting one to check out. So. Now, if you have done threat modeling, you may say, oh, this takes such a long time. It's just very intense effort. Yes, it is. It's a very brain draining effort. Can we automate it in this automating everything kind of era? Well, lucky for us, there is some effort. But the trouble is that the system model that feeds into finding assets and threats and other mitigations, if you do not have a good system model, your outcome is not going to be good. And this is why most security architects spend a lot of time creating a good system model. So the challenge is, how do you express your system in a manner that the computer can understand, right? So this is a new area. And if among you are intending to pursue your PhD, this might be one area that you can dig into and make our lives easier in a few years. So there are two approaches: threat modeling from code or with code. Now, the first approach of threat modeling from code is that it tried to construct the system model from the code itself. Now, here's a problem. Remember, I said the definition of threat modeling is to find weaknesses at the design time. We don't have implementation, but this threat model from code assumes that you have a code. So there's little bit contradicting points there. So I don't know the future of it, how it's going to take off or not. It'll be interesting space to watch. This bottom half is threat modeling with code, and this is it's basically annotating code but not really implementing it. That was the feeling that I got. But to be honest with you, I haven't had a chance to check out these threat modeling automation tools, and this is one of my goals this year. And if anybody want to inspect this with me, I would love to collaborate with you. But I put the links here so that you can go check out and learn about it. Now, I put additional threat modeling tools, and again, feel free to go out and check it out. Now, I have come to the point where I can do threat modeling practice with you. Again, this is taken directly from the threat modeling book that I introduced you to you earlier. So at this point, if you don't already have it, I want you to go grab a piece of paper and pen or pencil. We're going to do this together. Now, this is a theoretical industrial control system, and I want you to read it and construct on piece of paper what you think the system interaction, or what are the components that are involved in this system and how they're interacting. You can draw boxes or circles to indicate a different part of the system, and also draw arrows. You can have a directional arrows to indicate where the information is flowing. And if there are certain data that is being stored, you can indicate that data, the database box, usually that's in UML diagrams, you can use those kind of things. So I'm going to be quiet for the next 2 minutes for you to read and construct that. All right. I hope you have something on the piece of paper. Now, let's see. So in this circular diagram that I showed you earlier, we're at the system modeling stage. Previous page, you can look at it as use scenario, how this is used. And then now we're trying to construct an architecture based on that. And as part of development groups, oftentimes people do have design docs, right? You can utilize that as much as possible. You don't have to draw a special diagram just for this. But I'm a very highly visual person, and for me, it works really well. And I think most system model representation also has the visual aspect of it, and this is why I asked you to draw. And of course, in the book, it also represents the diagram. So if you recall that it's a IoT sensor where there is a valve control, it reads the data from the pressure monitor, and it interacts with this control and analytics service. And based on the pressure level, the reading levels, it either turns on and off the valve to release the pressure, for instance. Now, I like this example because it's very simple, but at the same time, this is very representative of real world implementation, as many of you know. So this is a good one to exercise with. Here you can see the directional arrow where which ones that the information is going and coming. Now these tiny extra, what appears to be looking like, say between a valve and valve actuator, there's a little tiny short arrow that looks like number 1. It's actually indicating that valve actuator is initiating the communication to valve when there's unidirectional information, bidirectional information. You wouldn't know which one is initiating that information. So again, valve actuator and sensor array to control analytics service. It's the valve actuator who's initiating that communication, even though they communicate bidirectionally. I hope that your diagram is something close to what is shown here. Now, but this is like too high level and maybe a little bit difficult to see what's the next level of threat modeling that we gotta do. So then, at this point, oftentimes what happens is the security architect would ask developers or the product teams, hey, give me a little bit more details and what's involved, what are the communication mechanisms. So this is the next level detail. And one thing that I want to point out is the dotted line around it. It indicates that it's a security domain right here. This is one security domain, and anything outside is a different security domain, which means that you are crossing the security boundaries. And these are the points that you have to be very careful in looking for a potential attack points. It's a blow up of how if you recall the reading, or if you go back to the previous page of the description, there's a shadow service. And so it kind of describes how the shadow service architecture would look like. Again, at this point, I would do, okay, where are the assets? So a lot of times you can do threat modeling based on assets, or you can just see where the attacks are. Again, there's no right or wrong way, what works best for you. I'm very comfortable with looking for assets first, because my reasoning is that without asset, what are we trying to protect, right? So where are the assets within my system? And I listed the assets, and I think a part of it is like from the book as well. Sorry, I don't mean to imply that I came up with this list. But anyway, if you look at the book, you will see these are the assets. And for all of these assets, you go through which of the CIA triad does it apply, right? And in the industrial control context, a lot of times confidentiality is not important. So you may have nothing applied in the sensor data aspect of it, but I kind of marked as analytics database as confidential. And most of the ML, the model developers, they consider their model to be very critical, and it's an IP, right? So that's why I kind of marked it as confidential. But in other cases, sensor data may be also confidential as well. The example is that you're a pharmaceutical company and you're working on a special, well, we have a good example, the vaccine, right? COVID vaccine needs to be stored at an extremely low temperature. So the fact that your temperature reading is very low, if it leaked, maybe it gives some clues to competitor that they need to work with something that works at a low temperature setting. So that could be also confidential. But in this particular example, it is not considered confidential. Again, we come to, okay, well, since we found out all the assets and what their, whether it's a CIA confidentiality, integrity, or availability, which one is important, now we try to identify threats and attack surfaces. And so these are the typical questions that you ask, trying to see how that particular asset could be attacked. And then in the book, it talks about the weaknesses and vulnerability that you find. And so in the interest of time, I'm not going to go over all of it, but here's the information that you can read. And now that we have, and this is just identifying the threats based on previous two slides that we talked about. And we come to mitigation part of it. So in the mitigation, how do you address this? So again, depends on what the threat is, you come up with a mitigation. And this takes a little bit of practice. There's additional resource that in the future, if we ever come across again, we could delve into deeper, but in the interest of time, I didn't include those in this talk. Now, we went over quite a lot, and we went over formal definition of it. I'm going to put threat modeling a little bit more in layman's term. If you had forgotten the formal definition, here's how Adam Shostack puts it, and it may be easier for you to remember. He's saying that we're asking these 4 fundamental questions. What are we working on? So if you think about it, that kind of maps to system model, right? We want to know what our system is doing, what can go wrong. This is identifying assets and threats and attack surfaces. What are we going to do about it? This is the mitigation. Now, the last question, did we do a good job? Remember I said earlier, it's an iterative process until you feel pretty confident that you've done a good job. How do you know? How do you know that you've done a good job? Now, when I first started in this domain of doing threat modeling, this is what kept me up at night. Did I do a good job? Did I find everything? Then over time, I changed my mind. Threat modeling at every stage, I'm trying to find as many as I can. It's okay. I may have missed it. There are even cases where I just spent a lot of time trying to find all the threats possible. And then in my previous job, there was a review board where I bring my threat modeling, and then it's reviewed by many security architects. And there was a really obvious one that I completely left out. Yes, I felt mortified, but that was the purpose of the review board, because we're human beings and sometimes we make mistakes, and it's okay. So I want to leave you with this message. Perfectionism is not the key to the success. Letting go of perfectionism is. So let go of perfectionism and try it out. And as you develop your system, think about what can go wrong and try to see how you can prevent it. With that, I return back to host Geeta.
Yep, sure. Yeah. Thanks a lot, Ms. Lee, for the talk. So we'll move on to the Q&A session and look for some interesting questions. Yep. Okay. Yeah, there is a question. Could you explain what's a shadow device?
Oh, so if you, I suppose that I'm going to share this slide deck, and in the example, I'm looking at the example. It's on slide page 39. When you get it, you will take a look at it. In this theoretical industrial control system, there is a system where you take the valve pressure reading and then controls the valve, right? And if you think about it, if you only have one system, and if that fails, it could blow up, right? So in a critical system like this, there's a secondary device that's inactive, but it is monitoring. It has all the capability to do control as well. So in this description, they talk about there is a shadow system that it's implementing.
Okay. So the next question is, which threat modeling tool is the best to use?
And again, what works best with you, and this is why you'll have to try it out. Now, so if you were talking about tool, I think you're looking at the automatic ones. And I'll be honest with you, I'm a little old school, so I do it myself, and I don't rely on automated systems so much. And so my experience is limited. But the tricky part is the one that can map your system as accurately as possible to the format that computer can understand. Again, that system modeling is key, because if you do not construct a good system model, then in the end, it's a garbage in, garbage out, right? So how do we make sure you may want to try out different tools to see how they accurately represent your system. I think Geeta is muted or...
Hey, yeah. So we have one more question lined up, which is which type of industry must have the threat modeling team?
All of them. But if you are, that's my opinion, but I'm a little biased. But if you are talking about anything that's interfacing external system, that's very important, anything web-based. But even products that are being installed at home, for instance, you know, let's talk about light bulbs, right? There had been a hack where hackers were able to hack into light bulb and get into somebody's house. So if you think about light bulb, who cares about light bulb being hacked, right? But the key thing is that light bulb is one of the components in a more expanded and system, like a home automation system, and it can provide the weakest link for attackers to come. Baby monitor, same thing. Baby monitor seemed like nothing, but again, it could be utilized to hack into the rest of the system. So I think that it should be exercised in all domains.
Okay. Another question is, as a PhD topic, what do you think can be done in threat modeling?
So I kind of mentioned earlier, while we're looking into automation, I think automation is not fully developed. That's how I think. So there's some aspects of automating threat modeling. And another thing is that I don't know if it came clear or not, but threat modeling is considered very time consuming and energy draining, extensive work. So if we can help automate this and get developers to aid developers to do this while they're doing their development work, I think it would be great help to the whole industry.
Okay. Next question is, isolating individual systems from one another. Will it be helpful?
Yes, I mean, isolated is as helpful as possible because you are not allowing one interaction to another. But let's talk about that. In the talk, I said the most secure system is the one that's turned off and not used at all, right? So can you do what you want to do by isolating all of these systems? If the answer is yes, can you afford to isolate them? Because that may mean that you may have to get extra hardware or extra setup. Maybe, but a lot of times you will find that the customers would want to minimize the cost in implementing something, right? So therefore, while that's your desire, from security perspective, that is not always the possibility.
Okay. The next question. What criteria is used to prioritize discarding threats during product design?
Discarding threats, meaning that you identify threats, but you are not mitigating it. Is that right?
Okay. Let us. Yes.
Okay. So this is why it's a team sport. You need to have multiple various stakeholders in place to answer that question. And there's no single guideline. It is about, but generally, this is what I use. I use 80-20 or 20-80, however you want to call it, right? So what are the most impact could I have with the smallest resource, right? And I try to address all of those, but there's always some corner case that is very difficult to actually make it happen from attacker's perspective. And let's say that it's especially high cost to mitigate it, then those are the high candidate to be put on the back, to be addressed later on, for instance. But this will be ultimately product owner's decision, business owner's decision, because you will find in reality that the business people will say, we need to release this product by this date, otherwise we don't make any money, right? So you would have to consult with them and come to consensus with full knowledge.
Okay. So I guess we are done with the Q&A session, and I guess there are no more questions. So thanks a lot. We have got really deep full insights into this topic of threat modeling. And also we would like to take a minute to thank our sponsors, VMware, for making this conference possible and reaching out to uh, the people who are interested in this particular field. So yeah.
Thank you.